Now we shall discuss another application of Cayley-Hamilton theorem. And of course we learnt the use of Cayley-Hamilton theorem. One will be to find out the inverse. Then another very important application will be to find out the power of the matrix. One can find out the power of the matrix. Here we are going to find out the power of the matrix. M matrix is given. We are going to find out m to the power 6. Similarly, m to the power 36, m to the power 100, one can easily find out. So use a Cayley-Hamilton theorem to find m to the power 6. M is given as this. So in the earlier problems, A is given as, here it is matrix is given. So we are going to find out m to the power 6. And of course the characteristic equation is given by this. So immediately we will have to find out the characteristic equation. How to find out the characteristic equation for 2 by 2 matrix? We know already A minus lambda I determinant, which is equal to 0. And you will have to go with this 1 minus lambda multiplied by 1 minus lambda multiplied by 4 minus lambda, then minus 2 multiplied by 1 with a minus n, that will give you plus 2. Simplification, you will have this equation. On again simplification, that will give you lambda squared minus 4 lambda minus 5 lambda will give you minus 5 lambda plus 6 equal to 0. So this is your characteristic equation. Cayley-Hamilton theorem says that lambda is replaced by A. Here lambda is replaced by m. So this becomes m squared minus 5m plus 6i equal to 0. Our aim is to find out m to the power 6. So first we will go for m squared. How to find out m squared? So m squared equals 5m minus 6i. You bring these two terms to right hand side. So that will give you 5m minus 6i. Squaring on both sides. Squaring on both sides will give you m to the power 4. So 5m minus 6i whole squared. See, a minus b whole squared formula. A squared minus a squared plus b squared minus 2ab. So you will have to use that formula. That will give you 25m squared minus 60m plus 36i. Okay. Now you just keep 25 as it is. Instead of m squared, you substitute 5m minus 6i. See here, 5m minus 6i. Then let it be like this. Let it be like this. So instead of m squared, we have substituted 5m minus 6i here. I repeat, see here, we have 25m squared minus 60m plus 36i. So 25, let it be like this. Instead of m squared, you substitute 5m minus 6i here. Then multiply 25 multiplied by 5, 25 multiplied by 6, then 60m plus 36i will give you this. I repeat, 25 multiplied by 5 will give you 125m. 125 minus 60m, that will give you 65m. Then similarly 25 multiplied by 6 plus 36i will give you 114. Okay. Now let us go for m to the power 6. M to the power 6 can be written as m to the power 4 multiplied by m squared. So m to the power 4 already we have found out m to the power 4 here. M squared already we have found out 5m minus 6i. So you will have to multiply these two. That will give you m to the power 6. So multiplying this by this, 65 multiplied by 5, that will give you this. Okay, 65 multiplied by 5 will give you this. Then 114 multiplied by 5 will give you this. Similarly, 65 multiplied by 6, that will give you minus 570m. So simplification, you will have minus 960m. So minus 960m. Then we have this multiplied by this will give you 684. Okay, instead of m squared, you substitute 5m minus 6i. So instead of m squared, you substitute 5m minus 6i. And let it be like this, and this one also let it be like this. So simplification, this multiplied by this multiplied by this, and simplification you will have 665 minus 126, no, 1266i. Okay, so we have 665, m is given as this, that matrix, minus 1266 multiplied by unit matrix. On simplification you will have this matrix, which is nothing but m to the power 6. So that's all. It's a very important problem. So there are two applications for Cayley-Hamilton theorem. One is to find out the inverse of the matrix. The another one is to find out any powers of the matrix. Any power. Higher powers of the matrix can be easily found out. So now we'll go for again one more problem. Inverse of a matrix. A inverse, we are going to find out A inverse. So A is given as this. A minus lambda is determinant. So that will give you this expression. So we have 2 minus lambda I squared minus 1 will give you 4 minus 4 lambda plus lambda squared minus 1. And of course 4 minus 1 is 3. So we have 3i and your lambda squared is here. Minus 4 lambda is here. So this is your characteristic equation. According to Cayley-Hamilton theorem, lambda is replaced by A. So that will give you this. Now that is the equation. Now multiplying on both sides by A inverse. Okay, A inverse. That will give you A. That will give you A minus 4 A inverse. That will get cancelled. Plus 3 I A inverse. So 3 A inverse minus 4I. Here it will be A. So you bring these two terms this side. So that will give you 4A minus A square plus 3I. So you have A inverse which is equal to 1 by 3 4I minus A. So 1 by 3 let it be like this. 4 is here, unit matrix, and A is here. Then you just multiply with 4 this matrix and subtract this matrix will give you this. So this is your A inverse. A inverse can be simplified as this matrix. Now how to check whether it is correct or not? So A inverse A, whether you have to get unit matrix. A inverse already we have found out A inverse. A is the original matrix which is given in the problem. So A inverse multiplied by A, matrix multiplication will give you this. Will give you this. 2 by 3 multiplied by 2. Okay, so 4 by 3. See 4 by 3. Minus 1 by 3 multiplied by 1. See minus 1 by 3. 4 by 3 minus 1 by 3 is 3 by 3. 3 by 3 is 1. See 3 by 3 is 1. Okay. Similarly, 2 by 3 multiplied by 1 minus 1 by 3 multiplied by 2 will be 2 by 3 minus 2 by 3. So that will go off. So that will be 0. Similarly, other terms. See here A inverse or A inverse or A inverse A, that will give you identity matrix. So this is verified. Okay, we can check where we have done correctly or not. So find the inverse of a 3 by 3 matrix. So matrix is given as this. We are going to follow the another method. Okay, you can also follow this method. Both the way it's same. Okay, so determinant of this will give you using characteristic equation, that will give you this. On simplification, you will have lambda cube minus 20 lambda plus 8 equal to 0. So this is the characteristic equation. Okay, so as usual, so you have 1 minus lambda multiplied by 3 minus lambda multiplied by minus 4 minus lambda. Multiply this will give you plus 12. Already one minus is there, so minus 12. Similarly, you can go for the next term with a minus sign. Go for the next term. On simplification, you can arrive this equation. So now lambda is replaced by A. So A cube minus 20A plus 8I. You are going to multiply with A inverse. So that will give you A inverse multiplied by A cube will be A square. A inverse multiplied by A will be I. A inverse multiplied by I will be A inverse. So you will have this equation. Our aim is to find out A inverse. So you keep this term, just bring other terms as it is to the right hand side. So we have A inverse which is equal to 1 by 8 times 20I minus 28, that will be plus 20I. A square will become minus A square, so minus A square. So 20I minus A square, you just simplify, that will give you A inverse. A inverse is given as this. You can also check whether this is correct or not by multiplying A inverse with A. That will give you answer as unit matrix 1 0 0 0 1 0 0 0 1. You can also check. Now find the inverse of the matrix 2 by 2 matrix using Cayley-Hamilton theorem. So now as usual we are going to follow the another method, lambda squared minus s1 lambda plus s2 equal to 0, where s1 is the sum of the diagonal elements. S2 is determinant, the value of determinant, and we can get 10. Substitute the values of S1 and S2 will give you lambda squared minus 5 lambda plus 10 equal to 0. Using Cayley-Hamilton theorem, lambda is replaced by A. So that's given as this. Multiplying on both sides by A inverse. So we'll have, there's a mistake here. This is A inverse. Okay. So A squared, A inverse will give you A inverse will be your I A inverse will be your A inverse. Our aim is to find out A inverse. So 10A1, you bring all those terms to the right hand side. So that will give you this. And 10A inverse will be, substitute the matrix. So that will give you this. And you have this also. Dividing by 10 will give you A inverse. Because 10A1 equal to minus A plus 5, we have simplified. And A inverse is nothing but 1 by 10, 4 to minus 3, 1. Simple. Find the inverse of matrix using Cayley-Hamilton theorem. So now again 3 by 3 matrix. So we have 3 by 3 matrix. Determinant A minus lambda equal to 0. So that will give you this. On simplification, you can get the characteristic equation exactly like this. Correct? As usual, 3 minus lambda multiplied by 2 minus lambda, 1 minus lambda, see here, multiplied by minus 1 will give you this. On simplification, you have this equation. Using Cayley-Hamilton theorem, lambda is replaced by A. So this equation becomes exactly like this. Now multiplying on both sides by as usual A inverse, we can do it, or we can rearrange the terms we have. So we can rearrange the terms. 2i, let it be like this. You just bring all the other terms to right hand side. So you have a cube minus 6a squared plus 10a. So you have 2i equal to, you just keep 1a out. So that will give you a multiplied by a squared. You just take 1a out, minus 6a plus 10i. Now you multiply on both sides by a inverse, that will give you a inverse, which is equal to a, and a inverse will go up. You have 1 by 2, this term, 1 by 2, the remaining term. So we have to find out now a squared. A squared minus 6a plus 10i. A squared is given as this, a multiplied by a. So a multiplied by a will be 3 multiplied by 3 plus 1 multiplied by minus 1, 1 multiplied by this one. So simplification, we can get a squared value. So this is for a squared. So a squared is given as this. A inverse will be 1 by 2 times a squared minus 6a plus 10i. So the second term will be 6a. We have found out now a squared. Okay. We have found out now a squared. A squared equal to a multiplied by a. So we have found out now 6a. 6 times a. So 6 times a. Then next one will be 10i. So a squared minus 6a. See a squared minus 6 times a. On simplification you will have this. Now 10i will be 10 times identity matrix. 10 times identity matrix. The formula is, the expression is for a inverse 1 by 2 times a squared minus 6a plus 8i. So we have a squared minus 6 times a plus 10i. So this is for a squared, and minus 6a plus 10i will be this. Already we have found out, we have simplified. So you have 1 0 minus 1 2 2 minus 4 minus 3 minus 2 7. Then a inverse will be 1 by 2 times. So 1 by 2 times of this matrix. So that will be your a inverse. So find a inverse if a is given by this. Okay. As usual, we are going to use this method. Lambda cube minus s1 lambda square plus s2 lambda minus s3 equal to 0, where s1 is the sum of the main diagonal elements, s2 is minus of main diagonal elements. Okay, sum of the minus of main diagonal elements will be this. S3 is det A is minus 6. So we have found out the values of s1, s2, s3. Substitute here. We will have this characteristic equation replacing lambda by a, that will give you Cayley-Hamilton theorem. This theorem. So this is the equation. Multiplying on both sides by a inverse, that will give you a squared a squared minus 2a inverse, correct? A inverse multiplied by a squared will be your a. 5a inverse will give you I plus 6a inverse I. So that will give you this, correct? So you have a squared minus 2a, this will be your I and this will be your a inverse, which is equal to 0. So we need to have only a inverse. So 6a inverse equal to, you bring all these terms to right hand side, that will give you minus a squared, minus 2a will become plus 2a, minus 5a will become plus 5a. So a inverse will be 1 by 6 times of this. And of course we can find out a squared. So a is given as this, multiply with the matrix multiplication will give you a squared. Okay, a squared is given as this, we have obtained. Now minus a squared plus 2a plus 5a, already we have obtained a squared, so a squared is here, plus 2a plus 5i. So just add, that will give you these terms, minus a squared plus 2a plus 5i. A inverse equal to 1 by 6 times of this, so 1 by 6 times of this. So this is your A inverse. So simple, all simple problems. So similarly we are going to verify Cayley-Hamilton theorem, and we are going to find out a to the power 4. In this problem we are going to find out a to the power 4. Let us do. So a is given as this, use this formula and find out the expressions for values of S1, S2, S3, S1, S2, S3. Okay, the characteristic equation is given as lambda cube minus 6 lambda squared plus 8 lambda minus 3 equals 0. Use the Cayley-Hamilton theorem. Lambda is replaced by a, so that will give you this equation. And first find out a squared. A multiplied by a will give you this. So a cube will be a squared multiplied by a. So your a squared already we have found out. This is your a. Matrix multiplication will give you the matrix of a cube. This is your a cube. So a cube minus 6a squared plus 8a minus 3a. So this is for a cube. This is 6a squared. This is for 8a minus 3a. So this is 0, 0. So Cayley-Hamilton theorem is verified. So it satisfies its own characteristic equation. Now we will have to find out a to the power 4. The another question is a to the power 4 we will have to find out. Now we know already a cube minus 6a square plus 8a minus 3a is a Hamiltonian theorem. We know already. So you just keep a cube, you bring all the other terms to the right hand side. So a cube equal to 6a squared minus 8a plus 3a. Multiply on both sides by a. So a cube multiplied by a will give you a to the power 4. Simple one. So now 6a squared becomes 6a cube. Minus 8a becomes minus 8a squared, 3ai becomes 3a. Okay. Now instead of a cube, you substitute the expression here. Instead of a cube, so 6 times instead of a cube, you substitute this expression. See here, other things let it be minus 8a squared plus 3a, let it be like this. Now on multiplication with 6, that will give you 36a squared minus 48a plus 18i minus 8a square plus 3a. So now this one 36 minus 8 will be 28. 48, see here 48 minus 48a, and we have plus 3a will give you minus 45a, and 18i let it be like this. So which is nothing but left hand side we have a to the power 4. So we have 28 times a squared minus 45 times a plus 18 times I. You just simplify, will give you this answer, which is nothing but a to the power 4. So this is what asked. A to the power 4, and we will have to find out a inverse. So we have found out a inverse, and this is your a to the power 4. Okay. So there are mainly two applications of Cayley-Hamilton theorem. One is to find out the inverse. The other one is any higher powers of a matrix can be found out. So one can also find out a inverse, multiplying on both sides by a inverse. This is the Cayley-Hamilton theorem. So a inverse will give you a squared minus 6a plus 8a minus 3a1. So 3a1, you bring this 3a1 to that side, that will give you 3a1. Remaining term, let it be like this. So we have a squared minus 6a plus 8i. Simplifying will give you this matrix, which is nothing but your A inverse, which is equal to 3A1. So 3A to the power 3A inverse. So A inverse equal to 1 by 3 times this. Okay.